안녕하세요, this is Mike from Rakers. I'd like to share with you the Rakers laser technology and its application in e-mobility manufacturing. Before I get started, I'd like to share my information with you. In the first 4 months of this year, 30% of the cars sold in China are e-mobility. Okay, let's get to the business. So, power battery is a critical part of e-mobility, and the laser processing is widely used in power battery manufacturing. As you can see, laser technology can be used in many applications here. For example, the wiring of electrode tap and the safety vent of scrap battery, and wiring of tap and current collector plate in cylindrical battery, as well as wiring of bus bar on pack module. So in these applications, Rakers ABP fiber laser can play a very important role. So why there is ABP? You see, most of the materials used in the battery are high reflection materials like copper and aluminum alloy. So it's kind of difficult for normal CW fiber lasers to deal with them. That's why we developed the ABP laser. It's adjustable beam profile, beam profile fiber laser. You see, there are 2 beams here. You see, this is the high power central beam and low power ring beam, and this is the high power ring beam and low power central beam. And here, high power central beam and ring beam. And this is only central beam, and this is only ring beam. So there are 2 beams, the central beam and the ring beam around it. And these 2 beams are controlled separately, and the switching time can be very short. So what is the advantage of ABP? There are 3. First, there is almost no sputter in welding. Second, the molten pool is large. Third, stable welding seam. These advantages comes from its unique beam design. You know, in welding, the ring beam will first preheat and soften the materials. Then the materials absorption rate to beam laser will go up. In the end, the molten pool is larger, and there is almost no sputter. So you can see here, this is, sorry. You can see here, this is ABP welding, almost no sputter. This is normal single CW fiber laser. You see there's a lot of sputter. Compared with the normal single CW fiber laser, the advantage is very evident, as they can solve some difficult problems here. For example, first, reduce pore to ensure tightness. Second, reduce cracks to ensure welding strength. Third, reduce reworking and ensure no pollution in the welding area. The fourth, lift the welding speed to ensure process efficiency. And seen from the metallograph, the welding pool is deeper and wider. And you can see the welding seam is smooth, and Fisher scale pattern is generated more easily. So this is the parameters. There are power redundancy, and in order to promote safety in use, interlock and current leakage protection functions are also applied to ABP laser. Now I'd like to share with you the applications. This one is top plate sealing welding. You see, this is the scrap battery. The 2 round objects here are the terminals. So in this application, there is high requirements on sputter. First, the top cap needs to be welded to the can, at the four edges. If the spotter drops onto the can, it may not be a problem at the time, but it may become a problem after it is installed, after the battery is installed into the car. So this application has high requirement. And in this video, the welding speed can reach 300 millimeters per second, and there's almost no sputter, and the welding formation is also good. So this is the data from a real battery production line. This is the picture of the battery in the production line. So the CPK, the metallograph data show the CPK is bigger than 1.67% qualified. And seen from 1 month production data, the yield of each day is higher than 99.6%. Okay, this is the second application, the welding of connection plate. So the location of the connection plate is on the other side of two round objects we mentioned in the first application. And in this video, the welding speed can be 200 millimeters per second, and there is almost no sputter also. And after welding, the backside is not overheated. This is the data from the real battery production line. The CPK is also bigger than 1.67, and the yield of each day in a month is higher than 99.6%. This is the third application, bus bar welding. You know, the function of bus bar is connecting battery cells in series. In this video, the bus bar is welded along square path, and the welding speed can reach 100 millimeters per second. And the metallograph shows that the molten point is large, and the welding quality is also good. This is the welding I'm helping, so there is also no sputter. This is the patterns we have so far of ABP fab laser. There are 22. So this is the 250 watt MOPA positive fab laser. It features high beam quality and small heat affected zone. So as a result, it can well meet the process requirements on tap cutting and electrocleaning, etc. This laser has been accepted by many top Chinese battery manufacturers. These are the parameters you see are the pulse duration range is very wide, and beam quality is high. The power instability is no more than 3%. This is a high power pulse fab lasers for cleaning. The power can be higher than 1 kilowatt. Its beam square, its beam support is square beam. So the output mode of beam support determines the damage to the base material and the cleaning efficiency. As its beam support is a square beam support, so its energy distribution is highly even, making it more suitable for cleaning. So this is one of the applications, the terminal cleaning. You can see here after cleaning, the color of the terminal is milk white and no metal luster. Here we only use the 120 watt laser, and the roughness is around 1.3 micrometer. After cleaning, the processing time is 2.45 seconds. Here you can see with different powers, the processing time is also different. If you use the 50 watt mobile laser and to clean around the area with 24 millimeter diameter, and if you need the cleaning depth is 5 to 8 micrometer, then the time is only need 1.3 seconds. This is the cleaning effect. The material is electrode. Just take a look. Okay, this is another application, the battery cell coating removal. So after cleaning, the difference of temperature before and after cleaning is only 3.1 degrees centigrade. Okay, laser is also widely used in body watt manufacturing. Let's go on to take a look at the laser's application here. So the first one is our laser used in NIO production line. NIO is one of the new forces in e-mobility in China, one of the leading one. So in this application, it's the top cover welding. 95% of 90% of the material is aluminum alloy. The welding tab here is a lap joint welding, and that capacity is 20 cars per hour. They use that laser. Okay, this video time is limited. I'm not going to show it. This is the beam switch type. The beam switch type of IFL C6000H. This is supported by BRD. So this laser is one of the best product of Rakers. It has more monitoring functions, and field bus function is also available. So the beam switch equipped on this laser is also developed by Rakers. There are 3 types: one-way coupler, 2-way, and 4 ways here. The coupling efficiency is no less than 96%, and is equipped with safe mechanical, electrical, and control monitoring systems. And the beam switch device is reliable, providing hundreds of thousands of times of continuous switching. This is the parameters about beam switch. Okay, here the last application is laser cutting of a thermoforming plate. General Motors use a laser to do such cutting. This laser cutting can increase the rigidity and strength of the material, at the same time lowering the weight and improve safety performance. As the cutting is very accurate, so there is no need of rework. Okay, time is limited. I just stop my sharing here. Thank you.
Thank you. Do you have any question? Actually, so before a question comes out, I ask you a question. When you showed the beam profile modification, you said you dramatically decreased the scatter formation in your welding. In that experiment, so what was the profile you used? What was the optimal? So
ABP, right?
Yeah, right, ABP. One is Gaussian, seems like, and the other looks like has a greater diameter cross-section.
Okay, so if you ABP can dramatically reduce the sputter because because of the rim beam and the central beam used together. If you just use the central beam, it's just like a normal single CW fibrillator. So in order to reduce the sputter, you have to use the rim beam together.
Well, if you use the modified beam, your effective diameter will be larger than the original case, right? So in terms of the power density, so power per unit area, are you using the same energy or same power density, or in the case of the MOPA modified beam, are you using actually the lower energy density?
You mean the
Because scatter, I think, is most strongly dependent on the energy density. Because if your irradiation is actually stronger, you will have a lot of scatter. But if you just simply decrease the power level per unit area, then you will decrease the scatter, right? So my question is, when you show the dramatic change, are the comparison really fair? Are they using the same energy density between those two cases? So that's my question.
I think, I'm sorry, I need to check more information with my engineers company.
Okay. Any other question?
Thank you for your presentations. You introduced the scale, flat top scale beam. You introduced the scale type flat top beam, right?
Pardon?
And there is some scale beam. Yeah. Scale shape.
Yes, square beam, yeah.
How do you make how did you make this kind of scale beam? Is it coming from a resonator or fiber or film shaping optics?
Yes, we have. I think that our fiber cable is different because all the fiber cables are developed by ourselves. So we have many different types of fiber cables. In the end, I can show it. Could you please? Because time is limited, I didn't show our the different types of fiber cables. Many different types. They're round, square, many. All developed by ourselves in the end.
Do you actually have fibers with a square cross section?
Yeah, we have a special fiber cable.
Okay.
Yeah, what's the maximum power of when you're using this kind of fiber cable? Maximum power.
Maximum. In our company, for example, this laser is a square beam. The power is 1 kilowatt, and in our company, the highest power is 2 kilowatt.
2 kilowatt.
Yeah. Thank you.
Okay. Is there any? I can get one more question. If any. Okay. I think that's it. Thank you very much. Let's give our speaker a big hand.
Thank you.